Madrid, capital of Spain, is also one of the most thriving European regions, a cultural, financial, commercial and industrial hub, which ranks third in the list of European regions in high technology employment. Madrid is a highly attractive region because of its dynamism and integration capacity, its excellent transport infrastructure, the highly skilled and flexible workforce, its leadership in aerospace and health sciences sectors, and is committed to becoming a technology leader in the 21st century. To foster this transition to a knowledge-based economy, the government of the Community of Madrid created the Madrid Institutes of Advanced Studies, a new institutional framework which combines public and private support to satisfy the needs of society by promoting research of the highest quality and ensuring the efficient transfer of knowledge to the productive sectors in strategic areas. IMDEA Materials Institute is the Madrid Institute of Advanced Studies devoted to the development of advanced materials to satisfy the ever-growing demands and needs of society. Created in 2007, IMDEA Materials Institute began its activities at the beginning of 2008. The institute is located in Tecno Getafe, a scientific and technological park located in Getafe, 16 kilometers to the south of Madrid. With more than 9,000 square meters, the new building provides space for offices for researchers and staff, 7 main research laboratories devoted to processing of advanced structural materials, processing of multifunctional nanocomposites, thermomechanical characterization, microstructural characterization, nanomechanics, and computational materials science. In addition, the building has an open area suited to organize international scientific workshops.
IMDEA Materials was born small, but the objectives were large, and they were 3. The first one was to develop research of excellence, to be an institution that is recognized among the best in the world in our area of research. The second one was linked to the first one, to do very good science, but science what was useful to the society. It means we were trying to promote technology transfer to industry to improve competitiveness. And the third one, that for me was the most important one, to attract talented people from all over the world to work in Madrid in an international and multidisciplinary environment. To do good science and technology transfer at the same time is not easy. In order to do that, you need a model. And the model we selected at IMDEA Materials Institute was that of a strategic partnership. It means that the industry benefits from the talented people we have brought to Madrid and from the research infrastructures available in the Institute, and they commit themselves to develop one or several of the research lines in collaboration with the Institute in a long-term partnership.
The selection of researchers is carried out by means of international open calls and is overseen by the Scientific Council of the Institute, constituted by 15 scientists with an international reputation in materials science and engineering. The current staff of the Institute includes nearly 60 researchers from 15 different nationalities. Approximately 50% of the scientists are foreign national, and about 65% of doctorates were obtained in prestigious foreign universities as Harvard, MIT, Cambridge University, Delft University of Technology, Max Planck Institute, China Central South University, among others.
My first degree is in physics engineering. I got it from a Mexican university. And then I also had a chance to do research internships in industry and in US labs. I moved on to a PhD at the University of Cambridge, working on the fundamental aspects of nanomaterials and how to produce macroscopic materials based on these. After a postdoc of 2 years at the same lab, I joined IMDEA in 2011.
Research of excellence is the technological key of IMDEA Materials Institute. Since the beginning of the Institute, the research activities have led to the publication of 160 papers in the most prestigious international peer-reviewed journals in materials science and engineering, 7 patents, 53 plenary lectures in international conferences, and to the organization of 15 international symposia.
We study the structure of metals by advanced microscopy and diffraction techniques, and we try to find out what is it in that structure that makes them strong or tough or ductile, or for example how this structure changes when we deform them at high temperatures or high pressures. And understanding these connections allows us to optimize fabrication processes for materials with improved properties that can meet today's industrial needs.
Research activities are focused on the development of advanced metallic materials and multifunctional composites for applications in aerospace, energy generation and transportation sectors. Processing and development of new materials is accompanied by the use of the state-of-the-art characterization techniques and the use of sophisticated simulation tools to model the processing and properties of materials and optimize their performance.
Our research is related to the simulation of the properties that would otherwise be achieved in testing. So in this way we can save a lot of money and time. So for that we need to measure some constitutive properties of these materials, then develop some models that simulate the behavior of these materials, and then with the help of modern computers we can actually predict where these materials were going to fail or to buckle under several situations.
The transfer of knowledge and technology from IMDEA Materials Institute to industrial partners is performed mainly through R&D collaborations in the framework of direct industrial contracts and competitive collaborative projects funded by national and international public bodies. Currently, there are 36 active research projects, including 4 supported by the regional and national research programs on materials, 14 by the 7th Framework Programme of the European Union, 2 international projects of the Materials World Network, which is jointly supported by the US and Spanish National Science Foundations, 4 projects supported by the China Scholarship Council, and 12 research and development contracts with industries. These industrial projects display our strategic partnership with multinational companies based in Spain, such as EADS, Antolin, Abengoa, Gamesa, Acciona e Industria de Turbopropulsores, as well as with a number of selected high-technology small and medium enterprises. In addition, IMDEA Materials has expanded its industrial links beyond Europe and has signed research contracts with Synopsys, Mountain View, California, USA, one of the largest companies in the design of an application-specific integrated circuits, and Global Foundries, Singapore, the world's 3rd largest independent semiconductor foundry. Internationalization of our portfolio of partners, together with the development of stronger links with Spanish strategic partners, stand as key features of IMDEA Materials' roadmap for industrial collaboration.
One of the more relevant parts of my job is try to find the more interesting research institutes and universities around the world in order to develop material and processes, mainly in the composite area. In this sense, IMDEA Material offers us a world-class technology, mainly related with composite material manufacturing technologies and also related with simulation technologies.
Cutting-edge research at the forefront of scientific knowledge and technology transfer to the industrial sector to increase competitiveness do not always go together. At IMDEA Materials Institute, we have demonstrated that 2 key factors to achieve this goal are to establish a long-term strategic relationship with selected industrial partners and to attract talented people from all over the world to work in Madrid in an international and multidisciplinary environment. And we plan to continue our journey along this road.